Test.
What's up? Hey everyone. Yo. As always, it's your boy. Wah, 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 wah. You know who it is. Another one of the master cuts by Nima. I don't know. I mean, really, as always, the font is font. So I'm going to try and zoom in as much as possible, but there's tons of real estate here in the front. So if you do want to move up close, that's cool. I used to get, like, I don't know if y'all know, I zoom in and all that, right? Have you ever seen anyone zoom in like I do? I probably not. Check out this level of zoom. Let's look up, I don't know, dogs or something. Dogs.com. People don't know this. There's multiple levels of zoom. Number one level of zoom, this is the zoom level most people are familiar with, is the command and plus. Like, all right, we understand that zoom goes up to a measly 500. Right there, I'm showing you a little bit of my power. Here's another bit of zoom. Maybe you want to zoom in on this word cyber a little bit. Whoop, there's a pinch zoom. Not a lot of people know this. You can pinch zoom. It's a different kind of zoom. Pinch zoom. All right, it gets us pretty close. And then there's the accessibility zoom. You have to like enable this. This is not enabled by default. You go into your settings. You look for accessibility. You check zoom. Wham! What? Incredible. You've never seen anyone zoom like this before. You're like, where's? I'm just trying to find just the dot on the eye. I make that dot on the eye fill up the whole screen. Right? So I'm going to start with that. Heads up, there's levels of zoom. How was I even talking about that? Right. I used to, when I first started lecturing, I didn't zoom in a ton. And people would be like, oh man, like, your lectures are fine, but I can't read what you're writing. Like, just sit closer to the screen. But then I learned to zoom, and now everyone's happy. So, hey, what's up? How's it going? How's your weekend? Pretty good? Yeah? Nice. It was your first weekend of boot camp. Should we make a list? All right, so today is week 2, day 1. It's quite a bit. Anyone do anything fun over the weekend? Slept? All right, sleeping? All right, so weekend fun? Right, define fun. Let fun equal, I don't know. Yeah. What's that? Same? All right, same. Anyone else do anything fun? That is horrific. You should take a little while after lecture. No more time for fun. You're like at the beginning of boot camp. Like, pace yourself. You know, people. I love people's journey through boot camp. It's like first couple of days, like fresh face. People are like, oh man, I can't wait to learn. And then they reach like day 3, 4, and 5. Like, oh man, people come back on, week 2, day 1, looking straight up like Sasuke from Naruto, just like, you don't know what I've seen, right? Like, wait it out. You'll be fine. Pace yourself. It's not easy, obviously, right? But you're gonna make it through, and honestly, by the end of this week, you're gonna be doing great. Week 3, it's gonna hit you hard again. End of week 3, you're gonna do great. Week 4, by week 4, you've got some solid makings of a developer. And week 5, I don't know if you've noticed, those students got like big traps, delts, like bowling balls. That's what happens. You code a whole bunch, yeah. They got bat wing lats, right? It's the ideal physique. Deal with it. No, I just wanted to put it on your roadmap. But like again, at the beginning of lectures in the first couple of weeks, I do like to remind you, like, treat yourself like a human being. I see no one with a bottle of water. That is terrible, right? I see one water bottle over there, and you're digging for the other. There you go. Right? Drink some water. Treat yourself like an actual human being. Get some sleep, right? And also just do some fun things once in a while. A lot of people don't know this. Coding doesn't have to suck, right? Like, you can have a good time. You can take a break once in a while. You know, these people, they're sleeping. Adam, where's your team, man? Yeah, they're probably practicing self-care, right? That's right. That's probably what they're doing. Adam, get out of here, man. Yeah. You know, sleep. Take a break once in a while. Hot tip: look up the Pomodoro method, right? Set a couple timers for yourself. Pomodoro technique is a time management method where you work for 25 minutes, and you take like a 5-minute break or whatever, right? Kind of don't realize the importance of this until it's the end of the week and you've burnt the heck out. Like I don't know what burns, candles, gunpowder. You treat yourself. Again, just come talk to me if you're having a tough time with stuff. But just want you to know that like it's okay to feel like this stuff is hard. I'm gonna put down. I went to Valle Lumina. It's up in Whistler. It was my anniversary this past weekend, and I thought, oh, you know what? Surprise her. I'll surprise my girlfriend. I'll take her to Whistler. It's like a 2-hour drive in an Evo. Not the economical choice, but I figured, hey, it's romantic. So also, it gets very dark as a person who drives in the city. Did you know it's like hard to drive in the dark? Really hard. So we get there, and then you take a bus, and as she's, like as we're getting closer with the bus, she's like, oh, is this like the lights thing? Oh, no way. I'm like, yeah, have you heard of it? And she's like, yeah, I went to it like last year. I should have asked. It still ended up being a good time. It was very cute. It's very nice. And that brings me to today's topic, which is, let me just show you a picture of what it is. This is very cool. Just a big old lights show in the middle of the forest. So in a roundabout way, that brings me to today's theme, which is test-driven development, aka ask questions, make sure you're doing the right thing. Right? I mean, it ended up being a good time. We ate pizza, hot chocolate, but it made me think. If only I had used mocha and chai, which you will learn today. So I'm going to touch on a couple different things today. I want to make this sort of more of like an interaction-based one, right? I'm going to keep some of these things sort of open-ended. You see there's not too much to the demo. Right? I kind of want you to push this a little bit. If you don't have much to push, that's fine. We'll just end early. Like, that's cool. These are the topics that we're going to touch on. I want you to feel by the end of the day, right? By the end of the lecture, and then also just by the end of the day, that you have some working understanding of what these things are. Not to say that, again, you're going to be able to use these things to their full extremes by the end of the day. You have quite a while to do that. But really, like, start integrating this into your kind of thought process about being a developer. I said last week that week 1 is about like learning to code. Everything else is kind of on top of that. You know JavaScript at this point. You know it. You could technically drop JavaScript, pick up another programming language, and do week 1 all over again. And you do it really quickly. You'd probably get through everything you did in week 1 with a different language in like 2 days, right? Then you drop it, pick up another language, right? Do it again. You're going to find that most of this stuff is pretty much the same, depending on the language that you pick. Right? So for example, if you were to go ahead and pick up Ruby right now, you have an easy time. For all intents and purposes, pretty much the same as JavaScript for what we're doing. Right? You go pick up Python, honestly, same thing. Want to go pick up C? By all means. C is not a very hard language. I'm seeing some, no, it's not that hard. There actually isn't that much to see. Right? These languages have a particular kind of frame of mind to them. And once you learn that frame of mind, you can translate anywhere. Oh, Python doesn't have semicolons. Oh no. Right? It doesn't have curly brackets. That's about it. Right? There are languages that are a little bit more difficult maybe to pick up immediately because they're a different way of viewing a problem. So if you said, oh, I've learned how to work with JavaScript, let's pick up Haskell, maybe not going to have the easiest time. It's going to take you a little while, and you're going to have to relearn a couple concepts because they're going to be completely different in Haskell. Right? But like 90% of useful programming languages, here's another one, Rust, Golang, right? You're pretty much kind of set for. Right? So the rest of boot camp, I don't want you to take a look at, I don't want you to like approach this as, oh, like I'm learning JavaScript really well or whatever, right? A lot of people come out of boot camp thinking that they're like, you know, JavaScript masters and they should only apply to JavaScript jobs because that's what they're competitive with. No, you're not competitive at anything, right? Like you are ready to just like learn what you have, right? And I mentioned this last week is like you have this ability to pick up stuff really quickly. You have this ability to follow instructions and to just be really excited. You have this ability to like take a 12-week boot camp. That's nuts. Right? So capitalize on that. So the things that we're going to be focusing on, you know, even starting today, are very like cross-language. I'm going to be using some tools that are built in JavaScript, work for JavaScript. Right? But what I encourage you to do is take these tools and Google alternatives. Right? You know, we're going to do Mocha, whatever the heck Mocha is. I want you to later Google Mocha for Ruby, right? You know, Chai for Ruby, because you're going to be using Ruby later in the bootcamp. Might as well just kind of see those words, right? Just put that stuff on your radar a little bit. You know, same with these concepts here, TDD and BDD that we're going to look at. These are not concepts that are specific to JavaScript. Right? These are development concepts. So today's lecture is split into, I guess you could say, like vaguely 3 parts to it. Say 3 parts. The first part is modules, right? The second part is Mocha and Chai. And then the third part is TDD and BDD. Right? Now, I know that you did a little bit of modules over the weekend. This is going to be a bit of a review. I find that modules are a really good thing to like have a very good grasp on. As you're going to find it's going to make your code a lot easier to write. It's going to make other people's code a lot easier to read. Right? And modules will basically unlock the full potential of what you can do with a programming language, right? In the 21st century. You know, why is this so cool? So I use the word modules. Right? What does module mean? Can anyone give me? You had like a reading, I think, in a quiz over the weekend. Does someone want to give me a soundbite of what this is? What does module mean? I mean, you could also just go look it up real quick. You could take a look at compass, steel, or maybe you learned. I don't know. Anyone have? Has anyone seen the word module? Yeah. Yeah, sure. In the Node framework, that's a good place to start. Any piece of code in Node framework. We'll dissect this, right? Any file. Sweet. Yeah, that's great. We're gonna dissect that. Any other like more kind of high-level description of what a module means? What are modules used for? Where do they show up? What's that? All right. So we're seeing the word dependencies, maybe. Does anyone know what dependency means? Yeah. So we're seeing the word require. Sure. Okay. What else? What does that mean? Right, there we go. In order for the program to run, all right, we need to have X. Right? That's the kind of I think a really good description of what a dependency or what a requirement is. So when we code, we use a programming language. There's many, right? Like I listed out a couple up here: Ruby, Python, C, Rust, Golang, JavaScript, Java. These are all languages. A language gives us like a very basic set of tools. Right? If we look at the language that we know right now, right, and this is something that we did a little bit last week, right, and I encourage you to come back to as an exercise. Say, what does JavaScript have? Right? By virtue of it being JavaScript, what do we have? What are my tools? Right? So that when I approach a problem, I look at my tools and I say, are any of these useful? JavaScript has for loops. Cool. JavaScript has several flavors of for loops. We've seen a couple. Right? For in, for of, for each. If I need to loop over stuff, JavaScript has that. Right? JavaScript has conditionals, right? In the form of if statements, in the form of case, like switch case stuff. You seen switch case statements before? Yeah, maybe, yeah. Right. So JavaScript allows me to do things multiple times. It allows me to make decisions. Right? It allows me to what else? Yeah, right. JavaScript has functions. Right. So bundle up some code, right, with input and output. Right. I put in some arguments, I get back some values. Functions are nice for that, right? Bundle up a bunch of stuff. So for loops, conditionals, functions. JavaScript has a heck of a ton of data structures. Right? And when I say data structures, I mean like, structures for storing data. Arrays are a data structure for us. Or we're going to say objects are a data structure. And JavaScript has a couple other ones too. There's a thing called set. There's all sorts of stuff. You're not going to really be playing with set in boot camp. There's limited use cases for it, but it's kind of cool. So usually when I look at a language, I sort of evaluate it on what it comes with. Right? If we really dig at JavaScript, there's probably a couple more things in there. Right? But it has these things. And sometimes this may be enough. Right? It may be enough. Oh, all right, well, I have an array. I have an object, I have a function, maybe that helps me solve a problem. At the same time, though, like I run into some limitations. For example, if I have an array, if I have an array, there are some operations that I want to perform on this array. Right? Sometimes I want to get the very first element. Right? Cool. JavaScript has that for me. They say, oh, well, you can go R square bracket 0. Neat. I want the length of the array. Okay, well, r.length. They've built that into the array. Okay, so there's some built-in stuff with the data structures that we have. There's some built-in functions just into the language itself. There's a math.random, for example, function. But sometimes even that's not enough. Right? The language comes with some constructs. It also comes with what I'm going to call like a standard library of things. Okay, the language itself comes packed with, okay, well, JavaScript has to have math, and it has to have array functions, and it has to have array functions for sorting, and yada, yada, yada. But there might be more specific things. And that's a place where like I might start writing some code for myself. Right? I'll say, hey, maybe it's very common for me to want to get every third element from an array. Maybe that's a thing that I just do very, very often. Right? I might make myself a function called const get every third from an array. Right? This is presumably a function that returns an array of every third element in R. Okay, cool. Maybe it's kind of useful. I want to be able to reuse this thing. Okay. Now, originally, what we might do as programmers, we want to reuse code in different files. We'll just have to copy and paste it over. Okay. It's not the worst thing in the world. We say, okay, well, if I need this function available somewhere else, unfortunately, what I'm going to have to do is be able to refer to it. So I'm going to have to copy it and paste it over. And after a little while, people get annoyed with that. Say, that's kind of dumb. I want to be able to package up my stuff. And instead of having to straight up copy and paste it, why don't I do the same thing that I do with functions, which is just call, right? Like with a function, if I have a bunch of code, instead of repeating it every time, I bundle it up. Here, if I have a bunch of code, instead of repeating it every time, maybe not in the same file, but across multiple files, it would be nice to be able to bundle it up. Right? And that's the general motivation for modules, right? The general motivation for this stuff is, regardless of what language you're working in, generally the language itself does not have everything you want. Right? It doesn't, like, it's impossible for a language to have every possible function that you can dream of. Right? Maybe I want to do a bunch of stuff with maps. Right? Calculate what is the distance between these 2 points given a particular projection or whatever. Right? If that was built into the language, like, that's cool, but there probably isn't a language with that. Right? So every single language that's like worthwhile is going to have some kind of package repository. Right? A package repository is an online place, usually, right, where you find little bundles of code that have been saved. Right? So if I looked up, for example, like some people like a language called PHP, I could look up Composer. Yep. Composer, and I just use that to get to a particular website called Packagist. Right? Packagist is a website that aggregates public PHP packages. You're going to find the words packages, modules, dependencies kind of used to mean the same thing. This is a place where someone has started storing a bunch of PHP code. Now, the code might be actually saved on this website, or it might be links to other places on the internet where that code is saved. Right? And this gives me the ability of searching for that code. And if I wanted to, I could copy and paste that code into my file. That's probably not the best way to use it, but I could. I could look up left pad. Right? Oh, here's a function that left pads a string to a fixed length. Left padding means if I have a string that is like 4 characters, and I say I want to left pad it with zeros to like 8 characters, that means it'll put as many zeros as it can on the left until it's 8 characters long. And might be a useful function for some reason. And here's left pad a string to a fixed length. I could find the GitHub for it. Here's a link to the source code. And here's the source code, and I could, if I wanted to, just straight up go, oh, here is the function left pad. Now, I don't code in PHP. I used PHP just as an example to show you this stuff happens in all languages. But I could take this stuff here and just copy and paste it technically into my PHP project. And, but this feels like a hacky way of doing things, especially as these things get bigger. And so people started making essentially scripts or programs that wrap around this process. Right? They're programs that, for you, what they do is they go look for this stuff, download it, and save it to your machine. Right? That's one part of it. And then the other part of it is there's also stuff built into, likely, the language that you're using to be able to load stuff from files. So there's a 2-part process to this. If I want to get some code into my project, I'm going to have to download it. So I'm going to need something that actually downloads that stuff. And then I'm going to need a process that loads that into my file. And over the weekend, you talked about sort of both of these. But I want to run us through that process because it's going to lead us into the testing stuff. Does that sound OK? Does anyone have any burning questions from like this past weekend or just like right now that you want addressed at the moment or you want addressed over the course of the day? Cool. If you do, by all means, shout them out at me. So what I'm going to use on the JavaScript side, right? On the JavaScript side is I'm going to start using a thing called NPM. Right? And you did a bit of reading and playing around with NPM over the weekend. I'm going to do this in 2 steps. First, I'm going to make my own module, and then I'm going to bring in somebody else's module to show you the slight differences. So if I go ahead and I make myself a file called coolfunc.js. Coolfunc, wow, I wonder what this func does. Const coolfunc. This is a function that console.log cool, right? I mean, honestly, it doesn't get much cooler than this. Let's say I make another file. This file is called app.js. Right? And in this file, I say, oh, console.log, wow, I wish I had a cool function. And then maybe another console log that says, oh, wait, I do. And then down here, I might call it coolfunc. I could try this out right now. Right? I could try running just node app.js. And it doesn't work. Right? It says coolfunc is not defined. Now, as a programmer, I might go, oh, that's not fair. I just defined coolfunc. I defined it in this file. Right? So what do I have to do in order to make coolfunc available in this file? I'll have to export it. Right? And you're going to find that in pretty much every programming language that you're working with, in pretty much every environment that you're working with, save for like a few exceptions. Right? Except for a few exceptions. So I'm going to have to actually say, OK, well, this thing here, this goes module.exports. Right? And what does this syntax look like? Module.exports, and how do I finish this? Equals. Cool. Equals, and then the function itself. So module.exports is specifically an object that I can throw stuff into. Right? In any node file, and this is specific to node. Right? Like the syntax is going to be different in other environments. Right? Node is only one JavaScript environment, for example. Right? In Node, I have access to this module.exports object that I can dump stuff into. And that's going to be convenient because the way that Node interprets every file, and this is something that one of you had said earlier, the way that Node interprets every file is that every file is a module. A node program is really just node, just the word node that puts you into the REPL. That's really it. And then the REPL, or this node engine, can take in files and interpret them. Right? So usually if we want to run something, right, we'll say node, and then we'll give it a file to run. And what node will do is it'll start from the very top. It'll make its way all the way down. Right? So if I say node app.js, it starts from the top, and it makes its way down. And that's all it knows. Right? This file is all it knows unless it's told to go read another file. And so I'm going to do this in 2 steps here. I'm actually going to get rid of this module.export stuff. Okay? I'm just genuinely going to get rid of it. Okay? What I'm going to do here is I'm going to go require. It's require. Yeah. Require. And I'm going to require the file coolfunc. Right? We're just going to see what happens. Right? Also, bear with me. I've been coding in Haskell for like the past 2 days, and I'm not very good at Haskell. But all I see everywhere is just Haskell code right now. I don't recommend it. I do. It's kind of fun, but. So this is legal code, require coolfunc. I didn't do anything, and in fact, I'm not even exporting anything on this side. Right? But I want you to see that if I go console.log, we really out here though. Right? When I run this right now, I'm running app.js. I actually do get we really out here though. Right? So the thing is, when you call require, what this does is this tells Node, oh, I'm going to stop looking at this file. I'm going to move over to this other file. And I'm going to read that entire file. And then when I'm done, I'm going to come back. Right? You can think of require as genuinely a function call. Right? Require is a function call, where the whole function is this entire file. If you wanted to return something from this file, you would use module.exports. Right? I find that to be a nice way to kind of think about it. Right? Require is a function call, and the body for that function is the whole file. So you want to be careful when you're requiring something. Right? Do you have some code in that file that shouldn't be running? Right? That's something that's worth thinking about. And so maybe I don't really want that here. Right? If I have coolfunc actually being called in this file, when I require it, it'll actually run. Right? Those are things to kind of keep in mind. This is this kind of stuff that like slips away from you once in a while and then comes back to bite you. Right? Just lessons that you learn over time. So I said if I want to return something, I use module.exports, coolfunc. Meaning if I want to actually get that value out on this side, I'm going to have to catch it. And in the same way that I catch stuff from functions, that's how I catch stuff from require. Right? So whatever you write on this side is whatever you exported. And that's something to really keep an eye on. Right? Now I'm able to coolfunc and actually use it within app.js. Right? The thing to kind of really keep an eye on is that this here, module.exports, allows me to export how many things? Like, how many things am I exporting right now? Just one. How many things can I export? Is that true, though? How many things can I export? Yeah. Well, I kind of get what you're getting at, but I'm going to say no, right? How many things can I assign on the right-hand side of the equal side? One thing. I can only export one thing. In the same way that I can, in JavaScript, I can only return one value from a function. There are other languages that let you return more things, but JavaScript made the executive decision. A function returns only one thing. Module.exports can only export one thing. But I can leverage the fact that I have data types in JavaScript that let me collect multiple things together as one thing. So if I wanted to export both cool function and const uncool function, console.log, what's an uncool thing to say? I'm not going to write that. I like to keep my lectures sort of apolitical. Also because I'm an anarcho-primitivist. Did you know this is a thing? Anarcho-primitivism? Did you know? There's some great memes about it, but anarcho-primitivism is the idea that agriculture, that whole agricultural revolution thing, huge mistake. That's the basic crux of it. Is like, nah, we had more fun and more free time as hunter-gatherers. All right. But I do like the very last sentence here. Just on the criticism of anarcho-primitivism. The Earth's surface would not be able to, support billions of people. So an anarcho-primitivist society, if we were to make a switch, it would require. It ends on the words, "the death of billions." That's a grim article. I'm like, all right. So yeah, I'm not gonna say anything political in here. We'll just say, nah, I don't really like saffron. Who doesn't like saffron? It's the best spice. Best spice, hands down. So if I want to export both of these things, I'm going to need to say, oh, well, export both coolfunc and I could do this as an array if I wanted to. Export both coolfunc and uncool func. What would be the difference? Between, when you say what would be the difference, can you give me a difference between A and B? Like between what? Mm-hmm. Yeah, exporting it as like as an array versus an object. What's the difference? Yeah, objects have keys, right? Arrays of indexes. Is there a difference? Not really, because over on this side, this just changes to, okay, well, cool func is the first one, right? And uncool func is, the second one. As an object, then I would go, I could go dot cool func, dot uncool func, right? Is there really a difference? Not really. You might notice that the code that I've written here, if we were to talk about refactoring, what would I probably refactor about these lines of code here? I might put them into like one object. Specifically, I'm requiring this thing twice, right? Which means I'm calling that file twice. Right? And keep in mind, requiring means calling, right? It just means calling and getting the output. Right? So what I would probably do for this is, stuff. And then I might go const, okay, cool func is stuff.coolfunc, right? If I wanted to just grab it like that. Or anywhere where I'm using it, I would go stuff.coolfunc instead like that. Trying to show you here that sometimes some of the code that you see can feel sort of magic. Right? If you take a step back, you see that this is a lot of this syntax, a lot of the stuff that you're going to run into is just a consequence of the structure of this particular environment. Right? Module.exports is a thing in Node. In other languages, it's going to be different. And even in other places where JavaScript works, it's going to be different. Right? I will find, for example, that when I'm working in the browser, so you're going to be working in the browser in the next week? Next week? No, in 2 weeks, really. You're going to be working in the browser. If I go in here, I don't actually have access to module.exports. Right? That's legal to do in Node, but it's not legal to do in the browser. Right? I don't even have module. Right? Module's not defined. So I want you to start thinking a little bit about how a language is not a thing that exists independently. Right? A language exists in an environment. Right? So we'll have the constructs that, we'll have the constructs that the language affords us. Right? The constructs that the language gives us, the for loops and all that stuff. But then a lot of that extra stuff, comes with the environment. So, yep. Module.exports and exports by itself. Technically, no difference. In fact, we'll find if we go in Node, module.exports, is a thing. Exports, export. Is that something you only have access to in the? Let me see. I'm just gonna in app.js, real quick. Go module.exports, and then exports. Yeah. So I guess it's only exports is only a thing that you have access to in a file as opposed to in the REPL. But module.exports and exports are the same thing, right? They're just references to the same thing. So if you didn't want to write the word module, you can just write export. Like other keys inside of a module? I mean, it's worth a shot. It's not going to be true for everything. So if we look at module, for example, there's things in here like parent, loaded, and children, right? Those are things you could try. Like what happens when you do parent? Looks like parent is not a thing that you can just access. So there are going to be some things in the language that have like shorthands to them. Right? If I'm working in the browser, actually some things in the environment that have shorthands to them. So in the browser, for example, there is location, but then there is also window.location. They're exactly the same thing. That's a really good question. So we have looked at basically two things right now. We looked theoretically at the idea that there is code that lives on the internet, and I want to be able to copy it and paste it into my file system. We've also looked at the idea that like you can make these modules locally, right? Files that you import, right? That you require. Right? So we can merge those two ideas. Right? I can have a thing that downloads stuff, and then I can also require that stuff in. Right? And that's where npm comes in. Right? So I'm going to pick any kind of package that I want. I could go on the npm website, where npm stands for, not a lot of people know this, npm stands for not particularly meaningful. If you click on it, never push to master. No packages, mate. Negotiable paleobotanist missions. npm stands for the Node Package Manager. Right? It's a package manager for Node. It's in the name. Is it the only package manager for Node? Absolutely not. There's other ones. Right? Here's another one, Yarn. Right? Yarn is infinitely better because it has a little cat on the website. Why wouldn't this be better? Look at a little mech cat. That's like me. This is me, right? So yeah, and then the logo itself is a little cat. Did you say this isn't you? So there are other ones. We're going to be playing with npm. I fully invite you to explore Yarn. Right? You're going to find Yarn does pretty much the same stuff with slight tweaks. npm has a web page just like the other one, the PHP one. If I look up left pad, somebody will have made some stuff like pad left, left pad, str pad. Oh, left. Which one do I pick? You know who I feel right now? Who I feel like? Rebecca Black. Which seat should I take? Except I'm like, which package do I take here? There's so many of them. How do I pick? That's the thing. Development is not without its social problems. Right? There are technical solutions to things. And as we find, technical solutions bring all kinds of crazy stuff. In fact, I'm reading a book right now, which is probably worth looking into a little bit, called Invisible Woman. Right? Data Bias in a World Designed for Men. Very interesting, really good book. If I finish it soon, y'all can borrow it. There's another one called Weapons of Math Destruction. Right? What happens when models or algorithms or tech makes its way into society? Like, what are the unexpected effects? Right? And yet another one called Race After Technology. This one I just bought. It seems really good. It seems very dry, but really good. What I'm trying to say here is I want you to start thinking about where basically the code and tech intersect with what we're doing as human beings. Right? One of those things is I look up some honestly meaningless package on here, and I see 87 different versions of it. Right? Not versions as in there was this, and then they made it a little better, and then a little better. There are 87 different people that decided to solve the same problem, but slightly differently, in the same language. Right? And that can get a little frustrating. So luckily, it being open source, I mean, I could just go into the GitHub repo. And GitHub repo, I'm going to open up some of these files. I don't know what lib does. Lib usually stands for library. Find myself some file. There's these two index files. I don't know what the difference between them is, so I'll open them both. This one here is written in TypeScript. I don't know TypeScript. But then there's also a JavaScript version. And so I could go through and, module.exports. That gives me a place to start. And then I see this, require WC width. So this person's pad function depends on some other package. Now I'm going to have to go to node and look up WC width. Here's another one. Let's go find this. We'll go to their repo. We'll go to index.js, I guess. Required defaults. Oh man, look, what's defaults? I'm going to go over to, there is a file called package.json that you've started exploring, right? Like I said, today, this isn't a tutorial. We're kind of diving a bit deeper into what you've already seen. The dependencies file for, part of package.json points to defaults. I'm going to grab this. And honestly, I have no idea if this is like a never-ending thing or what. Because when I go over to the GitHub for defaults and I take a look at their code, right? There's more. What? And if I go look at that, I mean, I have a feeling that this particular file, right? I mean, let's see how many people have downloaded this one. 9 million weekly downloads. 9 million weekly downloads. Let's see what this code is. This thing is huge. There's a file called clone.js. Let's see it. Okay, this doesn't seem like it's importing anything. So maybe this is the base situation, right? I might even be wrong. There might be more. I can always check the package.json, look up dependencies. Beautiful. The dependencies is just an empty object. I really recommend trying this out for really any package you want to use in the first little bit. This isn't something you should do every time, obviously. But like, as you're learning to work with packages and modules, right? Packages, modules mean the same thing. It's a good exercise to kind of dive in and see what is it. Because at the end of the day, all of this code, or at least most of this code, is going to be necessary for that one function that I want to use, which is that like pad function. And if I install node pad, okay, if I go ahead and I go, OK, well, where'd you go? Notepad, show me the npm. All right, so npm pad. I closed the page, so I have to go back to it. If I want to install this particular package, right, using the npm command, I'm going to find that all of the code that I just took a look at, like all of those files, will have to be downloaded. Right? And npm I pad. Whoops. If you click on this, it copies it to your clipboard. And here, in my terminal, I can go npm I pad. I mean, I'm going to find it's going to take a second or two. I'll ignore these errors for the moment. Added 4 packages from 21 contributors. Like, all I wanted was one function. But I got 4 packages. Now I get to open up my thing and see that I have a node modules folder. And that's where all of the stuff that I just asked for got downloaded. Here's the pad. And these are the other dependencies that I was looking at as well. Now we'll find that as I open this, there is the code that I was just looking at. Here we go. Inside of, oh, when you do npm install, it'll only download the dist folders. So not that lib folder. So often you're going to find that when you npm install, the code is like a little bit harder to read. For example, here, if I open this up, I thought that maybe it would have been like squished, but it didn't get squished. But that's all the code that I looked at before is sort of here, right? It's if anything just like a little smaller. Here's the defaults. That's in here. Clone. That's also in here now, right? All that stuff is there. Because if I want to use my particular function, like my computer needs to know where to find that code. And the best place to have it is on my machine. Doesn't mean I can't go edit it. I could go edit it if I want. But the thing is, this node modules folder, this thing here gets really big. Gets really big. Did I show you how big this stuff gets last week at all? No? I think I showed the other cohort. If you open up your project in Finder or wherever, and you check to see how big the file is, right now it's 80 kilobytes. I installed one package. But as I install more and more packages, this thing's going to get to like megabytes big of just code that I didn't write, code that other people made. That's fine. You're going to find that when you're working in JavaScript, you're very much like teetering on a skyscraper made up of other people's code. You're like, oh, I really hope something doesn't go wrong. I hope no one has any bugs in here. Like they do. There's tons of bugs. You're just going to have to deal with them. And that's why often people will publish updates to their modules. And when people publish updates to their modules, I don't want to stay stuck with the garbage code that I downloaded, right? I want to get the nicer, new, shiny code that they made. So I'm going to need some way of keeping track of what version I have, right? What version of each one of these modules. Again, this is the same in other languages. They're just going to have different kind of structures for doing this. But in JavaScript, what we have is we make ourselves, or let's say in Node, we make ourselves a package.json file. Right? You've explored the package.json file a bit, so I'm not going to go into the syntax of it, except to say that the package.json file is going to be the source of truth for where am I supposed to find the modules for this particular project, right? And what version are they supposed to be. Right? So that when somebody wants to use my project, they don't have to manually go npm install pad, npm install this other thing, and this other thing, this other thing. They should be able to just go npm install, and that'll read the stuff in the package.json. That's the idea. Right, so I'm going to show us this by first just using the pad function. I'm just copying in one of their examples. So pad, required pad, and we'll make a file called use pad. We'll just reverse this. So this should technically show 5 empty spaces and then the word pad. So and we got some empty space here. There's not 5. There's a bit. And I'd probably have to read the docs to really understand how to use this thing. Right? Again, pad, not a function I made, function someone else made, and when I npm install it, then I can require it. Right? Do you notice anything weird about the syntax here, as opposed to when we required other modules? Yeah. Yeah, go find this module, right? I would go // if it was something I made, right? But pad just means I assume that this has been installed, right? Oh, sorry, dude. I assume that this has been installed, right? So just go find it and bring it in. Right? And if it hadn't been installed, then it would say I can't find it. And in fact, that's what we're going to do. We're going to take this code that works at the moment. I'm going to delete the node modules, right? And delete the node modules, and when I run this now, it doesn't work. Right? And it doesn't work because it says, hey, I can't find the module pad. Right? Fine. It is totally fine for me to delete my node modules. Right? Because I shouldn't need to keep track of everyone's code. Right? The node modules is something that should get generated by my package.json. You can make a package.json by hand. You could go package.json and then write it out, dependencies, yada, yada. But npm init-y is more than enough. npm init asks you a bunch of questions about, what's the name of your project that you're making, what version is it at, write a description for it, what's the entry point, what's the main file for your project, a bunch of stuff. That's got a bunch of questions. Just taking your data. Now it's useful stuff, but if you just want to say yes to all the questions, you can just say npm init, and then this just says say yes to all the questions. Just press enter, enter, enter. And it'll make a blank package.json file. It looks like this. It kind of tries to be smart, like it comes up with its own name and whatever. You can edit this stuff if you want. You're going to find that by default, it doesn't have a dependencies section. And there's a lot of sections that aren't here. But as soon as I npm install pad, right, what's going to happen is I will get a dependency section now that shows me pad with a particular version. Right? What do these symbols mean? What does the number mean? Sometimes you see like, this thing or whatever, and a star. Go look it up. Right? There is a bit of a language that you can use to say, I want all the versions of pad that are within a particular range. So, because I know that maybe after this range or before this range, it breaks my program. Right? So maybe I want to stay within there. Right? Because as I said, people will like update their stuff. By default, npm just kind of sets it to a particular version. It says like, I think this means anything above here, within like not including 4, I think, but I'm not sure. But I'm going to find now that I npm installed it, wrote it into the package.json, it put it in the node modules. Right? I go node, use pad, and that works again. And even if I deleted the node modules, right, breaking my program, I can go npm install, and it will read my package.json. Right? It will read the package.json so that I'm back to being able to work. Right? So your package.json is the list, or among other things, is going to be a list of all the modules that your project is made up of. Right? These are all, and you use the word dependencies. Right? These are all the things that my project needs to be able to even work. So generally, when I start a project, or if I clone somebody's project that they've been working on, first thing I do, npm install, right, to get set up. As I said, though, like those node modules folders get pretty big. So you're going to want to not commit this stuff. Right? We might take a look at what that looks like in the second half. So, I mean, this is technically a lot. I know that you had seen a good chunk of this stuff over the weekend, but I wanted to give you this refresher. Right? I wanted to dive a little bit in deep. What we're going to do towards the end of the lecture, if there's time, is we're going to make our own npm module that other people can install. Right? It's fun. I think you even get to do it as a stretch exercise for low tide. So that might be something cool to take a look at. But we're more meaningfully going to dive into what Mocha and Chai are, which I haven't talked about so far. But I will say that they're npm modules. Right? Most of what you learn when it comes to JavaScript is just finding other npm modules and downloading them. Right? Are there questions about what I just did so far? Yep. That's a great question. There is a global node modules folder. If you go npm install and you go -g, -g means install this globally, so that any project or anyone on the terminal in any file can use that particular module. Some of these modules even expose some commands that you can use outside of JavaScript. I'll say that most of the time you don't want to install things globally. That's maybe a bit too much of a blanket statement. But if I have multiple projects, even if all my projects are using the pad library, right? These different projects may be using the pad library in different versions, right? Meaning there might be slight differences. And if I upgrade all of them to the same version, then it might break some projects. So it's a not so great idea to have your packages managed globally, right? Because I may be very happy with my stuff. Maybe I keep everything up to date, but then we're working on a project together. And when I put your project on my computer, maybe your packages are out of date, and now I've broken the project on my machine. Does that make sense? Yeah. So where to store packages is a really hairy question. And you're going to find that different languages come up with different solutions to that. For example, Ruby has a thing called bundler. Bundler is its package manager, or its version of NPM. Bundler is of the opinion that you should store all this stuff globally, and it comes up with an elegant solution for that. Right? So Bundler. Right? But there are other ones, and everyone has a slightly different approach to it. Yeah, that's a great question. So if I had installed something globally, in fact, we'll do that right now. I'm gonna delete this node modules folder so that technically it's broken, right? And then in my command line, instead of going npm install, I'm gonna go npm install -g pad, so that pad is installed at the global level, right? And we're gonna find that my project, doesn't work. What? They changed it up on me. What? Use global package. All right. Well, you used to be able to just straight up use. Yeah. See, they're used the same way. Install. This is August 2018. I don't know if maybe they changed it recently. I might have to just look it up. You kind of caught me on a technicality there. I'll say that what I'm used to is like if you had installed it globally, you could still require it in the same way. Evidently, that's not working at the moment, so maybe I'm doing something wrong. General answer to that, though, is just never install things globally unless you're absolutely sure that you should. Because what you'll notice is when I install something globally, even if, say, this example had worked, it wouldn't be in my package JSON. So somebody who downloads my project and tries to use it, they're not going to be able to install the dependencies unless they do it by hand. And that's annoying. I want to show you one last thing. Here's chai. Homemade chai. But we're not going to do any of that. We're going to look at the chai assertion library. I mean, look, I'm zooming right past this, so you can't even read anything. Isn't that frustrating? Yeah, I'm going to zoom right into here, so all you see is npm install chai. Right? And we'll just do it npm install chai like that. I just wanted to show you that I'm installing chai. So here's chai, and it comes with a bunch of stuff. And among the things it comes with, which we are really going to dive into, is this. So we'll do var expect equals chai expect. I'm going to have to maybe const chai equals, we'll do this first, require chai. Let's do that. So I have console.log chai. So something's there. This isn't an error message. This is an object with a bunch of stuff. Right? And all I want you to see is that if I go and do this, modify this code real quick, just const assert equals chai.assert. So I'm just grabbing a thing called assert out of this object. I'm going to go assert type of haha is a string. And I run this, and my code's fine. And if I do this, then my code breaks. That's all I'm going to show you for the moment. Right? Just these 3 lines of code. And we're going to take a break. And when we come back, we're going to pick up from here. Cool? Cool. Let's take a break until 11:20. Well, all right, welcome back. So we're gonna hop right back into it. Just gonna undo the stuff that I did earlier. So as I said, why am I doing this? Just that. As I said, what I wanted to kind of do with the first half was very much load it on modules. Right? I think modules are sort of, as a programmer, your most useful tool for productivity. Right? Generally, there's going to be a module for everything. Right? And that doesn't just mean, again, in JavaScript, that means all over the place. You're going to be using Postgres later in bootcamp. Postgres is a database. Think of it as a glorified spreadsheet, right? Or multiple spreadsheets. One of the things that a database like Postgres lets you do is ask, in this table or in the spreadsheet, like find me the person who has the highest number of goals in this year, right? Maybe they're soccer players or something. Something that doesn't have built in Postgres is the ability to say, find me all of the people who live within 3 kilometers of a grocery store. Right? That's an interesting question, but it's not built into Postgres. Right? Postgres does not have the language to do that. But there's PostGIS, spatial and geographic querying in objects for Postgres. Right? So if I wanted to ask a question like that, like find me all the people who are within 10 kilometers or 3 kilometers of a grocery store, right? I can install the extension PostGIS. Right? So in Postgres, they call them extensions instead of modules. And then all of a sudden, that gives me that ability. Right? I think this is pretty beast. Like I think this stuff is really cool. I've been playing around with it recently, and it's kind of nuts. So what's cool is that you end up with this language is just basically a shell of a structure. Yo, Jackson, sup, dude? Sorry, man. It's all good. So you end up with a language which is sort of like a shell of a thing. It's a starting point, right? And then you get to customize it and bring in stuff as you need. But as with any kind of customization, right, when you go a little bit too far, things get a little nuts. There's no real algorithm to like how many modules you should install or whatever. But it's something that I want you to ask yourself over the course of bootcamp. Do I need a module for this? Here's a question. I need to be able to add 3 numbers. Maybe that's the question, right? You look in Compass. Today's assignment number 1 is, you have the numbers 5 and 7 and 9, and you have to add them together. Well, I could just go online and npm add 3. Okay, no, that's definitely not it. But like, there's add 3 numbers together. Oh, hot diggity dog. Let me install this right now and solve my problem. Then the next question is like, add 4. Right? All right, well, I know how to use npm. Add 4. Nice, add 4. Right? This one adds 4 to a number. It doesn't add 4 numbers. Right? Well, the market's there, though, right? Maybe I'll make one, right? Like that's one way that you could approach programming, and it's part of the thing that some people in the industry find disgusting about JavaScript and about Node is that there's this obsession with just like using modules for everything, right? Sometimes it's not the appropriate thing. You just read a for loop, deal with it. So there are other things though where you definitely do want to bring some stuff in. For example, there are places where, as you're developing, you come up with or you want to use a particular mindset for developing, right? Whether that means a particular structure to your project, right? Whether that means a particular type of function that you're going to be declaring all the time, right? Or a particular type of set of objects, right? There might be packages or libraries. Libraries are, we were just having this conversation, libraries are just bigger packages, right? There might be stuff out there that makes that easier for you. For example, right, there is a concept called immutable data patterns. We're not talking about it right now. You're actually going to talk about it in 5 weeks, right? But I might, as a as a JavaScript developer, learn about this thing called immutable data patterns or immutable update patterns, right? And this might seem really cool. I might want to use it. JavaScript itself does not natively support everything that's needed for this. But if I Google enough, I will find immutable.js, which is a library, an NPM module that I will install that gives me access to some things that make that process easier. I'm not going to talk too much about immutable stuff. I just wanted to kind of throw that out there as like sometimes you make decisions, right? And there will be modules that make that stuff easier for you, so it's like worth using that. The decision that I'm going to make today is that I want to code following a test first, code later approach. Right? I want to take that approach. And I could, by all means, I could make myself files that have a bunch of console log statements, like the assert stuff that you've been doing. Right? That's what you've been writing so far, like assert equals, whatever, all that stuff. I could very much do the exact same thing. Right? So if I was to make myself a thing, and we're going to do count vowels. Isn't a vowel an animal? Yeah, that's pretty funny. Count vowels. There are 4 vowels. 4. Count vowels. Oh my God, JS. Oh, .com. You want to see something bizarre? The dude who made Node, Ryan Dahl. And Ryan Dahl, who I think now thinks Node was a mistake or something. I can't remember exactly. Ryan Dahl, I mean, I think Ryan's definitely in his Sasuke phase right now. I think Ryan's definitely is. No, there you go. So Ryan Dahl is the original developer of the Node.js runtime, right? Ryan has since created another runtime called Deno. Deno is cute because the logo is a dinosaur in the rain. Oh, or is it a snake? It's like a sock puppet. I've always seen it as like a brontosaurus or whatever, right? Deno. And Deno is just another thing that is essentially like Node. You know, you write your JavaScript stuff. But the thing that's kind of funny about Deno is that its packages, let's see, examples. You know what, Ryan? If you want your thing to be popular, like, make your documentation better, right? Like, I don't know, maybe that's just me. So the thing about, where are you at? There you go. Okay, so the thing about Deno is that instead of npm install, and instead of saving stuff locally, you go Deno, you give it a URL to be able to like install files or packages or whatever. They took like a really weird approach to package handling with Deno. So I wanted to throw that out at anyone who's interested in like, oh, what are the different ways of handling packages, like you mentioned. Right? Deno has a very weird approach to it, right? And you can still code pretty much like you would in Node. It's just got a strange package situation. That aside, I wanted to, what was I talking about? Right, about test-driven development. I could split my file up into multiple parts as I'm developing. Right? I might say that this is the actual implementation, right? And this is my tests. Very similar to what you've done, except you have like it in multiple files. Right? And if I was to make my count vowels function, right? Down here, whoops. Down here, I might go, okay, well, this is count vowels for hello world. And that should go 1, 2, 3. Right, so I might say, okay, well, it's console.log, count vowels, and then just the words should be 3. Right. Now, if I was to run node count vowels, undefined should be 3. Well, I have an issue here. It was supposed to be 3, so I can go and say, count vowels return 3. I made a mistake. I didn't tell you what this count vowels function is supposed to do. It's supposed to receive a string and return how many vowels there are. Is that all right? So this gives me a good, and I'm going to use the word framework here. It's going to give me a good framework for working on a problem. Right? I split my stuff into checking to see if it works. That's the actual implementation, and it gives me like a good loop as a developer to be able to like iteratively work on this. And you have been doing this in your own kind of bootstrapped way over the course of the past week. And so like count val is 3 now. I run it. Oh, 3 should be 3. We're getting to something sort of similar to what I did on week 1, day 2, which is I try to like implement just as little as I need, right? And now I make myself another test. Count vowels, ooh-wee. And that should be 6. Ooh-wee. Yeah, I can't remember how to spell it. That episode is really good. It's pretty funny. Ooh-wee. I'm in. What's the job? So so here's 3 should be 6. Obviously, there's something wrong. I can go back and I can change this around. This idea that you've already been working with is called test-driven development. You write some tests, you write some code. You write some tests, you write some code. And it's a loop. If I was to like codify this, test-driven development. You write some tests, just some basic ones, right? You write some code to make the tests pass. Write some tests to break the code. And then back to step 2. That's essentially it. Write some tests, you write some code, and then when the code makes the test pass, you write some more tests to break it. It's a self kind of punishing, just yeah, no, yeah, I guess it is recursive. It refers to itself and it's never ending, right? Like just code, break it, right? Until eventually you go, okay, I can't do this anymore, and you move on to something else. That is essentially the idea, right? And it gives us a good format for at least being able to steer our code in the right direction. If we're not testing our code, the fear is that we write code that works perfectly but doesn't actually solve our problem. That's the fear. Right? So the people who came up with test-driven development said, hey, we will artificially block ourselves from actually writing code. Right? We won't code more than we need to. We will only code to solve little bits of stuff at a time. Right? And if you take like a very strict approach to this, you will find that, sure, you might initially code a little bit less, but the code that you write will be more focused. The thing here, though, is that we need to be careful about like the tests that we write, because now that becomes a thing that we have to think about, right? So here now it's like, oh, for every one of the functions that I might have to implement today for my assignments, I'm going to have to split this into tests and split this into implementation. This is fine when Compass tells you to do that, because you're like, okay, well, I got to do it. But as soon as Compass stops telling you to do that, most people will just like, who cares? Get rid of it. Just run it. Let's just see what happens. They might throw in some console log statements in there or whatever, right? Part of the issue, or part of where this comes from, I guess, as a problem, is that like you have to set up a structure for yourself to test this stuff out. And as your programs get a bit more complicated, you know, they're not so much just input-output. Right? They have like actual behavior to them. Console logging stuff is not necessarily going to be enough. Alice? Right. So you asked about debugging last week. This kind of comes into that. Right? You have multiple tools as a developer to make code transparent to you, or to poke holes in the cheese. Right? One of those is just straight up console log statements. Right? Another one is using something like a debugger, a big weighty tool. Right? But a simple way of actually making code clearer to yourself is to have like a loop, like not a for loop, but a loop in action. Like you yourself go back and forth, and you continuously check what you're doing, and you tend to have a better understanding of what's going on. Test-driven development is a thing, and what we'll find is it's a little loop. Right? Write, test fails, write code, test passes. I didn't put this step in, but refactor usually, right? all your tests pass. Okay, good. There's probably still stuff that you can do to make it better. Take a look at it. Right? Are there more tests that you should be writing? Right? Or is the code that you wrote maybe not as efficient as it needs to be? Right? Or is there anywhere you can abstract a little bit? So if I was to take that approach to this, ooh wee, this should be 6. Now this thing is not enough for me to be able to say, okay, well this is what do you call it, like working. I'm actually gonna have to start solving this problem. Even if you get stuff down to like, what do you call it, a place. Like you can break these problems down into like really small pieces, but eventually you're just gonna have to tackle it, right? And this here is a place where I'm just gonna have to tackle how am I gonna count these 6 things here. I'm probably gonna need a for loop, right? I might break this down a little bit more. I might say, oh, console log count vowels for ooey. I might say, okay, well let's say that I only count e's, right? I only count e's. This number should be greater than 3 at least, right? It should be equal to or greater than 3. And that's a place that I can start, and maybe I would just code a little bit to just count e's. And once I'm happy with that, then I might go and just count something else and something else and something else, and just kind of incrementally build this thing up. Now, this process here is again sort of annoying because I've got this console log stuff. And the other thing that's annoying about this is that if I run it, if I'm working on a really big project, I don't just have 3 tests. I might have thousands, right? Like a big enterprise project built by dozens of people or whatever over a long period of time ends up with a lot of tests. And you want to make sure that you're not breaking that stuff, you're not breaking your code by making changes in the code base. So you'll run your tests frequently, right? Run command for tests, right? Node, run tests, or whatever. And I would like to be able to get a report of which ones broke, right? What tests didn't pass, why didn't they pass, which ones did pass, how long did the tests take to run, like all this interesting information. And I could sit down and just roll that stuff out myself. Right? Okay, here's a const, or let total tests is 3, let past tests equals 0, and then maybe every single time that one of these tests pass, I increase a value, and at the end I console log out or whatever, right? There's all kinds of stuff that I could do. But I feel like I'm doing more work than I need to be, so I go online and I look up test runners. Right? Has anyone made this kind of situation before? And the answer is yeah. 1 million people have. And Mocha is a test framework. And very similar to what you've been building out, but more feature-rich. Right? Because this is built by a ton of people. They've just had the time to build it. These are some people that donate. Then if we go on GitHub, we'll see that Mocha's been built by a grand total of like 427 people all contributing to it. And the basic idea behind Mocha is that it is just a big old Node project, big old JavaScript project that I'll be able to run some tests. That's the idea. Yep.
Is there usually one person that makes sure that people aren't changing things too much, or
Mm-hmm. Yeah. That's a great question. When you look at these open source projects, it can feel kind of weird to see 427 people. That's a lot. Usually, this repository here is owned by Mocha.js, which is an organization of 9 people, right? So they've made their project public. If anybody's free to go look at their code, anybody's free to clone their code, right, and play around with it. Anyone's also free to fork. I think you forked earlier in bootcamp, right? Anyone's free to fork. And the thing is, once you fork, you can make changes on your own version. And then when you want, you can submit a pull request. You go new pull request, and then you end up saying, I want to make a pull request from, and you would choose your fork over here to master. It doesn't actually make the change. It just opens up a thing that those 9 people can go take a look at. Right? And that saves them the trouble of having to write that code. And so they might see, oh, here, there's this person fixed this particular bug for the documentation or whatever. Right? And then they would go through, they would look at the files that changed. Oh, okay, it changed this stuff. Right? There's a description. And then at the end, the, Outsideris, who is a member of Mocha, they're one of the 9 people, they'll say, oh, I approve these changes. And different organizations might have, different rules about at least 3 people need to approve, or this person needs to be the final approver, or whatever, right? They might have their own kind of rules for that. And so it's kind of interesting to go see what the world of open source looks like. I run a thing called the Alumni Lab on Tuesdays, where people, after they've graduated, if they want to come by on Tuesday nights, we just sit down and we work on projects together. Sometimes I just give people projects to work on, and we build things together. Sometimes people just like doing some research on their own. But something that one grad has been doing is he's been going online and going on this project here. This is a platform for environmental organizations to be able to host events and whatever. It's open source. But Ben, the grad, he's been going on and just making pull requests to it. And there's 3 people who are the main kind of maintainers of the project. And they read the code that he makes, and then they just approve it, and it goes in. And it's, it's a pretty pain-free process, which is kind of cool. That being said, that's an interesting conversation. We might come back to that, later this week. That being said, I want to talk very, very lightly about Mocha. And the reason I want to talk lightly about this is because I want you to play around with it, but I also don't want you to get too stuck in the details as I'm setting it up. Right? I'm going to set up Mocha the way that the documentation is telling me to set it up. You're going to set up Mocha the way the Compass tells you to set up. Right? They might be slightly different. It doesn't really make a difference. Right? If it feels confusing, take a step back and just take a look at exactly what the steps are doing. Call a mentor over. We'll work you through it. But to show you, Mocha is supposedly a feature-rich test framework running on Node.js, right? Making asynchronous testing simple and fun. OK, all right, sure. Something about these testing frameworks is, if you look up this one called cucumber.io, this is another one of these testing frameworks. Tools and techniques that elevate teams to greatness. No, you're a testing framework. Fine. So what this really means is I get to go, and if we go down to installation, I can npm install global Mocha, or I can install Mocha locally from a project. Does it really make a difference? No. I'm going to install it locally as a development dependency, meaning that anyone who clones my project is going to have Mocha installed, but anyone who npm installs my project as as a package, it won't download Mocha. That's what a dev dependency is it's optional dependencies that are only useful if you're a developer. And if you're a developer on that project. Right? So left pad, I'm not a developer on that project, so it doesn't make sense for me to have the dev dependencies. So I'm going to go ahead and I'm going to say here, npm install save dev Mocha. It's going to take a second. In the meantime, I'll look at package.json, and I'll see that what it's added is dev dependencies with Mocha. Okay. And that's added 92 packages. It's a lot. But for me, it's just Mocha. I also mentioned a thing called chai. We'll look at that soon. Once I've installed Mocha, make my way over to the next little bit of documentation. Getting started. Well, they said npm install Mocha. I've essentially done that. Right? I just did save dev. This here is kind of annoying, though. Why are they giving me 3 different options for installing Mocha? Just give me one. Right? Welcome to the world of stuff being built by human beings. You're one of us now. Right? Then they say, oh, in your editor. All right, well, let me just copy this stuff over without looking at code, because that is safe. That is a very safe thing to do. We're going to go into, we'll make a. I'm gonna make a folder called old stuff. I'm gonna take literally everything except for the package.json files and the README. I'm gonna move all that stuff to old stuff. Right? Just so that like I'm not cluttering this. Is that okay? So you know when you want to see the stuff that I wrote in the first half of the lecture, it's in old stuff. In here, I don't know, mocha.js or whatever they're telling me to do in your editor. Paste that in. I'm not even gonna look at the code. In fact, I'll just close it. All right. Let me just close all the files. And then it says back in my terminal, I run this particular script. Oh no, no test files found in test. So I can like just immediately get angry, like, you didn't give me the right information. It didn't work. No, I just didn't read this properly. This said that when I want to add that file that I just wrote, it has to be inside of a folder called test. It says make a folder called test, and then inside of that, make a file. So I'm going to make myself a folder called test. Right? And I'm going to take that mocha.js or whatever I want to call that thing. What's your mother's maiden name? You know, just non-spam, non-malware stuff. Who knows? And when I run this now, well, it did something. And it printed out a nice little green check mark. I don't know what this does right now. I'm going to dive in. Mocha is going to give me basically an opinion on how it thinks I should keep my tests in one folder and my actual files that I implement stuff with in a different folder. Right? This is Mocha's opinion. It's not the best opinion. It's not the only opinion. There's Mocha's. Right? Mocha says you make a test folder, and for each one of your tests, or each one of your kinds of things that you want to test, you can make a new JavaScript file. And the stuff in here is going to say, bring in assert, whatever assert is. Now, assert is not a thing that I npm installed. Right? I only went npm install Mocha, but assert comes by default with Node. Right? You have it by default. And you require assert, and it's just built in. And then there's this describe function. Describe is not declared anywhere. It's not defined. In fact, I'm going to find that if I run that file, node test / what's your mother's maiden name, it breaks because it says describe is not defined. Right? Because describe is not a thing on its own. Describe is a thing that lives in Mocha. Right? And I'm not going to be running this file myself. I will tell Mocha to run it. And so this command that I glossed over, what this one here is saying is it says, go into your node modules, go into the Mocha folder of your node modules, go into the bin, which stands for binary, and then run whatever the Mocha script is. Right? There's a script called Mocha, or a program called Mocha that I can run. And anytime I want to run my tests, that's what I'll do. And it's going to go and it's going to find each one of the files that is under the test folder. It's going to load up any code that it needs for those files. And then it's going to go through each of these describe situations. So there's going to be a specific kind of language to this. This is what we call a domain-specific language, okay? Or a DSL. DSL is not a programming language. It's a result of us using a programming language in such a way that it even starts looking like another language. Right? So you're going to find that when you're using Mocha, you even stop forgetting that this is just JavaScript. You're like, oh, there needs to be a describe statement or whatever, right? It's just JavaScript. Describe. What describe is going to mean is I'm about to run a bunch of tests that are for an array. Right? I'm checking everything that's for arrays. And then here I put another describe because I'm getting even more specific. This isn't just for arrays. This one here is for the index of function of arrays. And here I get to describe every single thing about the index of function. Well, it should return -1 when the value is not present. This is human readable, human legible stuff. Okay? I can take this, I can even show it to somebody who's not, maybe not a programmer. If I had written this in like a nice enough way, the login function should log someone in. Okay? That's not something that like a non-programmer won't understand. And then I actually write some code to try to make that stuff happen. Right? So here, we're going to find that the index of function is actually being used. Right here. Okay? Array index of. And it's wrapped in this assert equal. And it's very similar to what you've been making, the assert array equal and assert deep. I think you made a deep equal, did you? Maybe not. You definitely did assert array equal, right? Yeah, that kind of stuff. All that is built into assert. The thing that's nice about this assert, though, is let's say that I had one that was broken. Right? Like, the index of 5 is not -1. Oh, wait. It's silly. The index of 2 is not -1, because 2 should have an index of 1. So this line here should break. And I run this now. If the thing breaks, Mogul will actually show me, OK, well, you have one test failing, right? This particular test here, the should return -1 when the value is not present. That one failed. This is how long it took for the test to run. Here's a really kind of well-defined description of what's going on. We expected that you would return -1. Yeah, we expected this, but we got this instead. Right? Notice how I'm already getting confused, though. I tried to sound intelligent, and I immediately got caught up on this. Because it's, even though it's able to give me multiple tests, like I can have multiple it situations. Okay? These are all right now testing the index of function. But if I wanted to test one of my own files, I would const require my stuff in here. We'll do that in a second. At the end of the day, my testing framework should give me like really clear explanations of what's going wrong. And I still, and this is personal, I still find this a little bit cryptic to read. And I find this a little cryptic to read, and I find this here a little cryptic to write. So what we have the option of doing is augmenting Mocha with a little bit of extra stuff, specifically changing up how this assert function works. So we're going to go find another library, and that's the one that I showed a second ago, when we took a break. And what that library is going to do is it's just going to give us a whole bunch of assert functions that are both easier to read and also easier to use. Right? So I have chai, chai.js.com, where I can npm install chai, and I just want to say chai is a test-driven development assertion library. All that chai does is it lets you replace the places where you go assert.equal, lets you replace that with assert length of, assert that there's a property, assert the type of something. Right? So it gives you this like sort of nicer syntax, little helper functions for that. Right? So I can npm install, just like I did before, npm install save dev chai. Right? What I get to do now is, instead of using assert here, I can go const chai equals and then require chai. And const assert equals chai.assert. So I'm not going to be using the default node one. I'm going to use my special one. Right? And I'm going to find that, likely all my stuff still works fine at the moment. That still works fine. But I have the benefit of being able to go ahead and write some slightly more interesting assertions as opposed to just assert equal. Right? To do this, we'll just make the count vowels function really quick. Right? So, yeah, const count vowels of a string. We'll return. I don't know. We'll go for let vowels. This is just going to return a number that starts up at 0, but for const char of string, if char equals a or b or not b. What is it? A, E, I, O, and U. It's not the best code, but it'll work. A, E, I, and then O, and U. And it's only going to work for like lowercase letters right now, but it doesn't really matter. Then we'll go vowels plus plus. And then at the end of it, I'll return vowels. I don't want us to worry too much about the code itself. Let's just assume that this is a function that, given a string, returns however many vowels there are that are lowercase. And I'm going to make my very own assert stuff. So we'll build that from scratch so that you see it like just right from the beginning. We'll start off by having this describe situation. Where describe takes in some text. I want to describe count vowels. And I want to run this right now. We've got, OK, there's describe count vowels. There's no real tests going on. And then even deeper inside of describe count vowels, just want to make sure I have the syntax right. Even deeper inside of describe count vowels, I can go, describe the kind of return values. Right? Right? And this is very much just helpful to me. Like I'm leaving notes about what I want to test. OK, well, I want to test the kinds of return values. I'm going to go ahead and say, here, it should return a number. And I get to pass this another arrow function. It should return a number. And each one of these its, each it is a test. Right, so now I have one test. Does this test pass or fail? It might fail, and we'll run it. It passes. It passes because I don't have any assertions in here. Right? In order to make a test pass or fail, I need to have asserts. Right? So assert, and then maybe assert that the type of a particular thing. So maybe we'll go const result equals count vowels. Vowels for hello, my name is Nima. Right? In this one here, I want to just check that the return value is a number. So let's just check that the type of result is a number. Right? I'll go ahead and I'll test this, and it passes. It returns a number. And if for some reason I was to break this so that it doesn't return a number, but it returns some string, right? Now this is broken. I want to be clear, I flipped this right now. I didn't do test-driven development because I wanted to show you a little bit about Mocha. Right? What test-driven development would mean is that I write this stuff first. Right? I write this stuff first, maybe even before count vowels exists. Right? The test breaks, it tells me why it breaks, and I fix that issue and then just run the tests again. Right? That's test-driven development. Honestly, there's just so much marketing around it, I think. It feels like a bigger thing than it really is. Eric, how do you feel about it, man? TDD. You don't do it. We all know about it, but we don't like really do it. You should. You should totally do it. Be the change that I wish to see in the world. You should be the change that I wish to see in the world. You should start doing test-driven development because it's a good thing to do. A step beyond test-driven development is this thing called BDD, behavior-driven development. What the heck? Behavior-driven development? What is behavior-driven development? It's just test-driven development, but the asserts are written in a slightly different format. So instead of me saying assert type of, this is TDD, I say expect result to be a number. And this is that. It's that. I just have to make sure that instead of bringing in assert from chai, I go var chai equals, or const expect equals chai expect. That's it. And now I'm technically following behavior-driven development. Right? Expect result to be a number. Right? And then the errors that it prints out, I mean, I find that the errors that chai prints out are like a little bit nicer, right? But some people just like the syntax. I wish I could give you a better explanation for this, but it's literally some people just like this syntax as opposed to this, because this feels more English. It feels more non-technical, and they can get non-technical people in on writing tests. Right? Expect result to be a number. Oh, okay, well, I expected it to be a number. Here's the number. Right? If anyone asks you what behavior-driven development is, it's test-driven development, but written in an English way. Does it get more than that? Yeah, there's should syntax. If you wanted to use should, you do chai.should instead of either one of those two. And now what I get to do is foo should be a string. So result should be a number. And it's the same thing. It's just some people looked at expect and they're like, oh, that sounds a little aggressive. Let's say it should be a number. And that maybe aligns a little bit more with like the kind of language that business people use. Right? And that's it. You now know test-driven development and technically behavior-driven development as well. Right? To run these tests, you constantly just go / and then just the same command. Or you copy this stuff and hold on to your seats here. You go to package.json. You see this scripts thing? You paste that in here. Right? You paste that in there. And then now what I'm able to do in my command line is go npm test. And it runs my tests. Right? And that was the last thing I wanted to show you. We'll probably talk about npm and uploading stuff just the next time I lecture with y'all. It's interesting, but it's not worth spending time on right now. Question? Probably not related, but could you show how a function can throw an error? How one of these functions can throw an error? Yeah, like for your vowel. Yeah. I mean, I just wanted to throw an error. Ooh. Have you talked about try-catch yet in bootcamp? Okay, I'm going to say no. We can talk about that individually, but I think there's a lecture on that stuff. That's a really good question, though. Cool. Right now, we just won't worry about it. Cool? Cool. I'll send this stuff out as soon as possible, but in case you don't know, you actually have access to these notes, in general, lecture notes. If you go to your day, okay, and then you scroll down to click on the lectures and breakouts, and then scroll down a bit, you actually see previous lecture notes with videos. So you can click on view to view that stuff, and they go back forever. If you want to see how I did this 4 months ago, there I am. Right? You want to see me like, I don't know, slightly skinnier, better dressed, then just go further back and you get to watch. Yo, Steve, nice sweater, dude. Very nice. But yeah, so I wanted to let you know you can check out other people's lectures that way. Cool. Have a great day. I'll send out notes as soon as possible. Thanks, everyone.